This video contains an overview of the investment simulation module and some theory and examples for stationary transformation and the fully flexible resampling method. So this should be a really good start for you to start working with your own data, including missing data imputations and things like this. So first of all, just to give you an overview of the system, the idea is that you as a user will come with the market data that's relevant for you and input it into this investment simulation module. This module contains a lot of data pre-processing functionality, some imputation functionality if you have missing days or differing holidays, and then different investment simulation engines. The idea is then once you have loaded the data and you have performed calibrations of these risk models and performed simulations, then you will have some P&L and risk factor simulations that you can work with. So this will be fully general Monte Carlo paths for as high dimensional markets as you want. But the thing is, of course, once you have these simulations, it's not going to be immediately clear to you how you should build your portfolios in a smart way based on these things. So this is why we have the investment analysis module. So basically you can perform the simulations, you can store them on the cloud disk that is available to you, and then you can load them in the investment analysis module to perform all the stress testing, the views, and discretionary adjustments that you want to do using, for example, entropy pooling. And then after that you can optimize portfolios, you can analyze the risk, and finally decide on which portfolio you actually want to implement. So this is the big system overview that was also given in the first video, and now you have it visually. So here you can visually see how the investment simulation module looks. So basically your main user input in relation to data is this historical market data. This can be everything you want. So it can be prices, interest rates, credit spreads, implied volatilities, and FX rates. And then the first thing you will do is to perform some stationary transformations such that it makes it easy for the different risk models to learn from this data. So this is the stationary transformation class where you can also perform the low-level transformations yourself if you want, but we recommend to use this class. It makes things very nice and easy for you. If it happens that you have days where you have missing data, so let's say for instance you have stocks from the US and from Europe, then the holidays might differ and you might have days where there's an N. The question is then, what should you do? Just throw away this day completely, or should you try to infer some value for this missing value so you can use it for resampling, because it might just be a couple of observations that miss this particular day while you have everything else available, so it would be a shame to throw it away. And this data imputation, you can do it with the time series variation autoencoder class. So this is something that we'll be going through later, and it's something that you can see in the final examples if you want. The idea is that if you have this missing data, then you can get these stationary transformations, including the imputed values. If you don't have any missing data, then after the stationary transformations, you can just directly feed them into the market simulation methods that we have here. So we have something very simple if you want, but it's not something that we recommend with parametric sampling. So basically we allow you to sample from the normal and log normal distribution if you want to do that. But what we see is that people prefer to use this fully flexible resampling method because it works in very high dimensions and it has some intuitive economic interpretation. But there are also more advanced statistical methods that you can use with this time series variation autoencoders and time series scans. So basically here we provide very elegant frameworks for you to work with these things and make sure that all the state is handled correctly, because this is something that is very challenging for tabular time series that we usually have in our data. Whichever method you choose to use for the market simulation, you will end up with simulated future market paths that should have similar characteristics to the historical data. And this is what you can use as input to the investment analysis module to try to make sense of these simulations.